In this video, I will be showing you how to build an image captioning application using Gradio. For the agenda, first I will do a quick project overview, then I will go over the components. After that, I will do an architecture breakdown, then a quick code walkthrough, and then lastly will be the demonstration. For this project, I will be basically showing you how to create an image captioning and generation application. You will basically be able to upload an image to the user interface, then a description of the image along with a new generated version of the image will be created and outputted. For the components, first we will use Jupyter Notebooks to store our code, then Hugging Face will be used to find the most suitable large language models for this project. Those large language models we'll be using is the Salesforce Blip image captioning base, which will allow image to text, and then we will use the Runway ML Stable Diffusion v1-5, which allows text to image. So lastly, we'll be using Gradio to make the interactive user interface for this application. I'm going to do a quick architecture breakdown. So first, the user will create a Jupyter Notebook through Anaconda, which will display via the internet. Then we will retrieve our LLMs needed for the application, which will be retrieved from Hugging Face. Now, Hugging Face is similar to GitHub, but solely for AI, so it allows you to build, train, and deploy machine learning models and share them amongst the AI community. And for this video, as stated before, we are using two different models. So the first one will be the Salesforce Blip image captioning base, and then the other one is the Runway ML Stable Diffusion v1-5. So I'm going to quickly show you how to use Hugging Face and how we can retrieve these models. I just want to go over the Hugging Face website and how you can use it. Up top, we can search models, datasets, and other users within Hugging Face, and you're also able to have your own account and create an own account for free. So I have pulled up our Blip image captioning base model that we are using, and we have a model card here which basically provides the key info about a machine learning model. We have a architecture breakdown as seen here, and you are also able to test out the model. So I'm going to just upload an image of a dog smiling. And here it generated a caption, a white dog with its tongue out. And that's exactly what the image is. So the Blip image captioning base is image to text. And then we have our stable diffusion model where we can change text to image, and we can test it out here. So we can say a person smiling, and we'll press compute. And here it's generated an AI image of someone smiling. Hugging Face is a great website for just trying to get acclimated to different machine learning models and people that are creating these models as well. Lastly, Gradio will be used to create a web interface for the machine learning model. So this is what will allow you to upload an image into the box, and then it will generate your caption. And then once the caption is generated, it will generate your new image. Now I'm going to do a quick code walkthrough line by line. So first we have our necessary libraries we need to import. So we have our import OS, which is basically file and directory manipulation. After that, we have our import IO, which just provides tools for handling data streams in memory. After that, we have our from IPython display import image, display HTML from pill import image. And basically this allows you to display images, control how things are displayed, and embed HTML content within the Python environment you are working in. And then we have our import base64, which encodes binary data into text. Here we have our from.environment, import load.environment, and find environment. And here we are just setting environments by loading our variables from a local env file, and then it retrieves the value of the API key, the HF API key, which stands for Hugging Face API key, from the environment variables using OS environment. Then here we have our import request JSON. So this is used to interact with web APIs and handle JSON responses. So here we are creating a function called getCompletion that takes in 3 parameters, which includes inputs, parameters equals nones, and our endpoint URL. So now we have to set up our headers for the HTTP request, which we are doing here, and then we will create a dictionary with the input data. After that, we have to make a post request to the specified endpoint, and then we will parse the JSON response and return the result. So now here, this line is basically assigning a value of an environment variable named HF API TTI base to a variable named TTI endpoint, which stores the Stable Diffusion Models API. And then here we are essentially doing the same thing, but the other way around. So we're doing the HF API ITT base to a variable named ITT endpoint, which stores the Salesforce Blip image captioning base API, which is image to text. So now I'm going to start the application building process. So first we are defining a function called image to base 64 string that takes in a parameter pill image. So here it basically saves the image in PNG format to a bytes IO buffer. Then it will convert that buffer to a byte array, and then it encodes that byte array to a base 64 encoded string. And then a base 64 encoded string will be returned. So here we are defining another function called base 64 to pill, which takes the base 64 encoded image string as input, and then it decodes the base 64 string to a byte array. After that, it will convert the byte array to a bytes IO buffer, and then it will open an image from the bytes IO buffer using pill, and then it will return a pill image. Here we have a function called Captioner, which takes in the parameter image. And what that will basically do is convert the image to a base 64 encoded string using image to base 64 string. And then it calls the getCompletion function with the base 64 encoded image and the image to text endpoint, the ITT endpoint that we just worked with. And then it returns generated text from the API's response. Our function generate that takes in a parameter prompt, and basically it calls the getCompletion function again with the text prompt and then the text to image endpoint. It then converts the base 64 encoded image from the API's response to a pill image using base 64 to pill, and then after that it will return a generated pill image. So now here we have another function called caption and generate that takes in a parameter image, and here we are creating a Gradio interface with an image uploaded component. We have a button to trigger the image captioning and generation, and also we have text and image components to display the results. The interface will allow us to upload an image, click the caption and generate button, and see the generated caption and image after the button is clicked. And that is basically it for our code walkthrough, and now I will get started with the demo. Now I'm going to show how the application works. So I'm going to double click here, and my picture of choice is Mona Lisa. I feel like it's the easiest, but you can use any image that you'd like. I'm going to click open. Then I'm going to click caption and generate, and we have to wait a few seconds for it to load up and render. So here is our generated caption. Afraid picture of a painting of a woman with a smile, which is Mona Lisa. And then our new generated picture is a woman with a smile and a painting of a picture once again. And you can use any image you want. Again, it's not subjected to the image I just used. And yeah, that's basically how the application works. And if you have any questions about this project or just want to get more information, please feel free to email me at jsing_tech@yahoo.com. Thank you everyone for watching.